I'm Brandon Gullah. I lead up engineering at Rancher Federal. Thank you for joining us for the Public Sector Edge Computing Roundtable. Edge computing is transformational relevance across the entire public sector landscape. Today, we see edge computing models and paradigms evolving to better support mission objectives in both defense and civilian agencies. Edge computing naturally enables compute resources to deploy when and where the mission is happening. In this session, we will discuss how edge computing can increase situational awareness, augment fleet support logistics, and provide better data analytics for civilian support. Given the broad value add that edge solutions bring, we will also discuss how security is addressed in this area. Here with us today are our esteemed panelists. We have Key Lee, Vice President of Strategic Innovations Group for Booz Allen Hamilton, Sean Wells, Vice President of Solutions Architecture at CrowdStrike, Major Rob Slaughter, who's the Director of the U.S. Air Force Platform One Initiative. So with that being said, let's go ahead and get started with the questions. First up is Key Lee. Key, Booz Allen has taken the position that edge computing allows data to be acted on beyond the IT enterprise. What is Booz Allen's approach to address the public sector edge?
Yeah, thanks, Brandon. And first, before I answer the question, I just want to thank Rancher for coordinating this conference. I think it's extremely relevant, as you mentioned earlier on. And I'm looking forward to the panel with Rob and Sean. To answer your question, I wanted to start, we started with a hypothesis, right? Our hypothesis was that with the growing number of sensors and the data that they were constantly going to generate, the current paradigm of bringing data to some central cloud, centralized processing area would cripple the internet. So based on this hypothesis, we really thought that we needed a different paradigm and really start pushing the process to the edge. And so our definition of edge, just to be clear, is at the point of data collection. So as you mentioned, it's not just at the edge of the IT boundary, which is also relevant and valuable, but we really think the force multiplying effect will be when we can actually do processing on the edge device themselves, whether an IoT sensor, an aerial, maritime, ground platform, mobile devices, or even on a soldier themselves, right? We've actually taken a holistic approach to this. It's not just a technology problem that we're looking at. We've looked at it from an entire workforce perspective. There's not enough embedded engineers out there today, right? All the way to sustainment. I think what people are forgetting is when you start putting software on these devices, there's a tail, there's a cost associated with that, right? And Sean's gonna go into the cyber aspect of it, so I'm not even gonna touch that, right? So our approach has been really taking a look at historical patterns and such. We've actually been investing in something that we call a sensor processing unit, an SPU. This is a software-defined platform that's designed to be deployed on any heterogeneous platform. Again, I think just looking at historical patterns of IT and infrastructures, we believe that focusing on this kind of software-defined capability, and that's where containers, Kubernetes, K3Ss all come to relevance, and is I think relevant for this conversation.
Great. Key, you mentioned the cost of supporting edge deployments. Do the benefits outweigh the move to edge?
I think so. Again, back to my point earlier about learning from the past, right? We have to learn from our historical lessons learned and make sure that we do take this holistic approach to this. So, part of the way that we've been thinking about it is, and again, I know Rob will be talking about some of this as well, but taking some of the platform one concepts, right, and actually pushing stuff in containerized, immutable software baselines all the way to the edge devices themselves, right? My colleagues actually supporting U.S. Air Force are actually doing this right now. We've actually deployed edge computing capabilities on a U2, right? And we're actually using a K3Ss and that kind of DevSecOps to the edge to make sure that we can actually deploy rapid capabilities, right? Secured capabilities faster in real time.
That's great. I saw a tweet about that this morning, and it's a fascinating mission, and you guys must be honored to support that. So a follow-up question, in the DoD space, people have called edge computing a force multiplier, a term that is used a lot. But from Booz Allen's perspective, can you expand on this idea?
Yeah, from a warfighter perspective, and let me just focus on the warfighter for right now, because there's just so many different use cases that we've identified, right? But from a warfighter perspective specifically, I think one of the key measures of impact is time, right? And how do we reduce that time of data to decision, right? And we really think that this edge computing paradigm will really short circuit that OODA loop, right? If you think about how data is kind of gathered, collected, brought down, shared, and then it's a reactive kind of request for information, right? That's time that our warfighters are sitting there without information and potentially actionable intelligence, right? So if we think about that as a key measure, we think that that the force multiplying effect will be when we actually allow for decentralized decision making, right? There are two, I think, key examples of this already in action. I think the DoD leaders across DoD are really kind of pushing the boundaries and the edge, no pun intended, in this manner. One example of that is within the U.S. Air Force and the Advanced Battle Management System, right? U.S. Air Force solution for Joint All-Domain C2, and the vision of this Internet of Battlefield Things, right? The second one within the Army is this concept of the digital warrior, right? And Army's vision of this broader digital battlefield, right, to increase soldier and squad lethality and survivability, which I think is important, right? So I do believe, Brandon, that edge computing will be a force multiplier, not only from a warfighter perspective. I just talked through that one use case, but other use cases across DoD as well.
That's great. Well, thank you, Key. We're actually going to send it over now to Sean Wells for the next round of questions. Sean, edge topologies represent a break from classically hardened perimeters one would find in a traditional data center. As a leader in threat intelligence space, working closely with U.S. public sector entities, how does CrowdStrike approach securing devices at the edge?
Sure. So classically, we've kind of followed this 1-10-60 rule, where the idea is that we detect threats within the first minute, understand them within 10 minutes, and then respond within 60. And kind of along that line, at least through our intelligence feeds, we've kind of seen the average breakout time for all observed intrusions rise from about 4.5 hours to 9 hours in 2019. And when we think about that, it really reflects a dramatic rise in e-crime attacks. So they have significantly longer breakouts compared with nation states. And what's interesting is, at least for this audience, for the government audience, there has actually been a reduction in breakout time from nation state adversaries, whether it's the classic Russia and China and so forth. And as we think through the edge as being slightly different than the data center, what was kind of compelling, at least in our views, in 2018, about 60% of the attacks were malware, 40% were malware free. As we move into now, late 2019, early 20, it's actually the use of malware has been reduced. About 49% of attacks are malware and over half are malware free. And what we mean by that is when CrowdStrike says malware free, it's basically attacks that don't result in a file or file fragment being written to disk. And these include things where code executes from memory or where stolen credentials are used. So tying all that perspective together to like what's our approach to securing at the edge, we really do a couple things. The first is that we've started to secure the pipeline itself. So classically, a lot of our tools are CVE based or common vulnerability enumeration. Basically, there's a known vulnerability. We detect if a package has that known vulnerability and we patch it. But in reality, over half the attacks are using malware, which will never have a CVE. They'll never be able to be picked up. So it becomes this question of what are we doing as a government with NIST, with OPM to build out software bill of materials, and a upcoming, currently in process work that we're doing with NIST revolves around something called software ID tags. And the idea is we decompose the workload on the edge, whether it's a container or a bare metal. We take all the files, all the packages, whether it's a web server, And we can actually compare that to a known good list. Like, is this truly the Apache web server, or has it been mucked with? But what it also allows us to do is take all of the software um, that is known during development and actually run it through malquery or malware queries or bad file lists. So now the secure process begins actually at the build time for workloads running on edge versus the runtime. So that's been a big shift that we've been working on specifically with NIST, actually.
No, that's great. It seems like you're taking a much more reactive and proactive approach, much more proactive approach than reactive, especially with CVEs. You're going to understand that these threats have already been identified, but you're taking more of a proactive stance in identifying these threats before they might even be into the common ecosystem, right? They might be 0 days or something like that. So it seems like that's a much more proactive approach.
Yeah, it's so that we try and decompose it. So the first stage is really about securing the pipeline. You certainly have the secure the runtime, so you're running an agent. With CrowdStrike and Rancher right now, for example, we have a Helm chart that deploys the sensor, so it becomes an intrinsic property of Kubernetes on the edge clusters. So that way we have the observability, and that's kind of like the table stakes. But where we're going is the ability to not just gain near real time awareness of software that's executing, but also fuse it with threat intelligence. So, right now, for example, in the CrowdStrike land, we're observing about 4 trillion events per week, tracking over 145 threat adversaries, so the nation states, the e-crimes, and so forth. And what we've ended up finding is manufacturing remains the top targeted vertical, and U.S. public sector is the second. So the challenge about threat feeds is historically they're like intelligence reports that you get in a PDF and you read them, and you got to track 145 PDFs per threat actor. Like it's just untenable. So wouldn't it be nice if we can fuse the classic threat intelligence about a particular adversary going after finance or telco or government, but embed it or enrich it with machine code to say, hey, this is a detection pattern, or hey, this is a Yara or a snort rule to find out if you've ever had an incident similar to one that's been captured in the past. And we're actually working, I don't know why I have NIST on the mind today, but we're working with NIST on an open source project called Rolly. And the idea is to kind of create this autonomous response system such that if a government entity, the Library of Congress or Department of Interior sees something, there can be a common data taxonomy that captures what happened, as much attribution of the actor as we know, as well as codifying the signatures. I shouldn't say signatures, but codifying the metadata around what happened. Is it a memory execution? Is it a certain file? What's the hash of the file? What were the techniques they used? And now by sharing that in an open feed, essentially we can create this community across defense, intel, civ, from big government agencies like DoD to small state and local shops, all exchanging threat intel that is actionable, being able to write firewall rules or software allow and deny lists all dynamically. And that capability is just now coming to play.
No, that's great. On the same topic of, advanced persistent threats and adversaries of that regard, how deep in the stack do we actually need to go to stay one step above with the devices being deployed in hostile environments?
So right now, at least in the CrowdStrike view, we have an open source threat intel center, and we track, again, 140, 150 adversaries. So we certainly see device tampering in terms of like supply chain and manufacturing process, but it comes to really attestation of the device itself. So things like Intel's trusted boot and device guard technologies, all the way through software, we call it software ID tags, SWID, the software allow and deny list. So when you say how deep, it's really we used to be able to say like the defendable perimeter or something like this. Now we're actually measuring the device itself, what software it's using to boot, has it been tampered with, all the way through runtime. Um, So I'm not quite sure how to answer the question. Like it's really not just one layer anymore.
It's a partnership of the hardware manufacturer and the engineering company with, how deep they go with the trusted compute module, as well as the software side and, higher up the stack of actually integrating those checks and, creating opportunities to blow a fuse or to trigger some sort of tampering interface. So it seems like a coupling of both the hardware side and higher up the stack that together they can deliver the type of security needed. Would you agree?
I do, and it's also not just about the device, and that's where I feel like we get tripped up so often. Is we're focusing on runtime of the device or tamper or malware, but in reality, like if we take e-crime, which is the majority of the 2019 and 2020 activities, there's now malware as a service where companies literally exchange malware, and that actually starts on the developer laptop. So if we're going into a automotive situation or a manufacturing, how do we fuse everything from phishing attempts and random downloads on a developer laptop tangentially or laterally moving into your dev environment, maybe messing with your code, and then that code gets, whether using something like continuous integration or continuous delivery, gets automatically pushed to your edge. So it's really, I think the question is better if we pivot to the holistic framework of like, what does it mean as we move to software enabled defense and software enabled government versus this endpoint specific. And I realize that's blasphemy coming from an endpoint detection company, but that holistic view, I think, is a better question and a better awareness of what's really happening.
That's great. That's great. I'm actually going to ask the next question to both of you guys, but to give Sean a little break, I'm going to tee it over to Key. Key, new security models seem to be required to protect edge computing devices and software. What new approaches have you considered, deployed, or think we should be aware of as we approach this new paradigm in computing?
I think Sean answered it really well. I mean, it is kind of a holistic view that we have to take, right? It really is about, in my mind, it's about mission resilience at the end of the day, right? And what does resilience include, right? And the threat isn't just malware and so forth, right? I think it includes, when you start putting stuff out there, it includes things like electronic emissions, right? So you don't want to be identified and targeted just based on your IW, right? I think the second thing, and both Sean and I mentioned this as well, in the classic kind of, I think, cyber aspect of it, how do we get patches out to these edge devices, right? And I mentioned it earlier, right? You have to look at the sustainment of this and make sure that it's scalable and cost effective, right? Otherwise, we will crumble under the burden of just sustainment costs, right? And the last thing is operational security, right? The art of the possible with edge computing, at least in the digital battlefield, and even other use cases like predictive maintenance, sounds great. But we also need to make sure that we have OPSEC as well, right? Because when you're starting to carry around these edge devices that give you intelligence, what happens if that puck on a soldier, right, gets in the hands of the adversary, right? So I think the security models, the way that we're looking at it, is kind of holistic. It is about, I think, mission resilience. I think we have to look at it kind of holistically. This is a next gen platform, right? I firmly believe that edge computing will be kind of the next version of the internet. It won't be terrestrial based. It will be space based, right? I just think that we're a ride here, exciting ride, but we have these pretty deeply.
It's interesting that you said next generation in that fashion, next generation of the internet, because while you and Sean have been speaking so far, I just keep thinking in my head to the term Internet of Things and how it almost feels like the Internet of Things has evolved into edge computing proper.
So I'm glad you said that, Brandon. I don't like the term IoT. And the reason I don't like the term IoT, I know that globally that is kind of the term, but for our warfighters, and actually it's not just DoD, there's civilian entities as well, right? The I in internet implies that you're connected, right? The fact is, some of our civilian and war fighters aren't connected, right? They operate in that disconnected intermittent low bandwidth environment, right? So, and if you take a look at history, right, I do think this will be the next evolution, or I've been reflecting upon since I came out of college, right? I've gone from mainframes to PCs, client server, internet, cloud, mobile, IoT, right? And then just kind of reflecting upon that, what I've observed is that when industry invests in infrastructure, it becomes a leading indicator of an IT evolution, right? And I think that's where we're at today.
Absolutely. Well put. So Sean, Key just mentioned operational security and OPSEC. What's the CrowdStrike approach to observability? And all the things is not a good answer.
Sure. So, oh, wow. So on the actual endpoint, whether it's x86 compute or an ARM-based device, we certainly have the ability to tie into kernel level at various operating systems. So you said observability. So in that way, we become an intrinsic property of the actual operating system, and we can see everything that's going on. But classically, that observability has been isolated, right? This trigger on this endpoint, and then you get a million ServiceNow alerts, and it's really not that good. So observability, I kind of alluded to it, is really transitioning to really measuring the whole software or endpoint manufacturing process, meaning the is it a trusted device with the following signatures and the following BIOS, and has it been mucked with? The code that goes onto that, whether it's the BIOS or the operating system, Intel would call it trusted boot or TPM, down to the software bill of materials, down to the insider threat concerns of, why, for example, is Brandon logging in at 2 a.m.? He never logs in at 2 a.m. So how do we, or maybe you do, but how do we identify the outliers of behavior and the outliers of process versus some random detection in ServiceNow? And some of the, actually a shout out to the Air Force. So they have Platform One and the Iron Bank. And what's really interesting about their authority to operate, or their ATO, is not so much the configuration and monitoring of the endpoint, like are we stigged, do we have FSMA, this or that, but they're really ATOing the manufacturing process. Do you have change control? Are you monitoring from development to integration to test to prod? That observability, the ability to fuse all of that intelligence together, is kind of where CrowdStrike's going. And then you certainly infuse that with the classic threat intel of what nation states are going after government, or what criminal activities are going after manufacturing. So tying together your organizational process with awareness in the market, that, I would say that fusion is kind of where we're heading.
Well, it's funny you bring up that fusion, because the first thing that popped in my head was, from a behavioral standpoint, behavioral analytics, you're thinking of a traditional analyst, for a government agency, or an analyst that are tracking that. But then it's also the digital signature side. So you're fusing those two different work streams and thought processes. And it's almost like the maturization of the DevOps type of model, where you're fusing those to produce a synergy that's a whole new stream, right? Do you see this as, the next step in behavioral and digital analytics, to combine these in a way that picks out needles in the haystack that we didn't even know we were looking for?
I do. And I guess as the cybers, we always talk about Russia and Iran and China. And in reality, there's all these economic factors too. And maybe a story that's covered well in the press is, in 2018, the Vietnam-based actor group Ocean Buffalo was implicated in intrusions targeting automotive. And it kind of expanded from their classic, financial, government, other nation state scope. And why don't I say that? It expanded from their geopolitical intelligence gathering and recon, and basically indicated Vietnam was going after economic espionage. And what was happening also at the time in the world is that it coincided with, I actually wrote notes, but it coincided with the Vietnamese Ministry of Industry and Trade going after domestic auto projects. So now we're seeing this intersection of nation state intent tied to adversarial activity. And how do you tie that even further to, if you're automotive, you kind of want to feed like that nation state threat intel to your awareness. So yeah, the whole socioeconomic I keep saying fusion over and over, but the whole socioeconomic fusion of intel is probably the most paramount next generation that we can achieve.
It's an exciting time. And, Sean, you said a lot about, the barriers that Platform One is breaking down, both from the software accreditation pipeline, but also, the actual accreditation pipeline in general, when it comes to certifying the hardware and the approaches there. And I know Key was teeing up a lot of the great work that Booz Allen is doing with Platform One, and the broader U.S. Air Force. We might as well go ahead and hear from, the man behind all of this, Major Rob Slaughter, who's joining us from the U.S. Air Force, who is the director of Platform One. The DoD's Platform One initiative has been leading the charge in a lot of ways, especially in the cloud native transformation throughout the Air Force and the broader DoD as well. Can you give us a quick overview of Platform One's mission and the value that it brings the entire community?
Yeah, absolutely. So, first of all, thank you for the kind introduction. As mentioned, I'm Major Rob Slaughter. I'm the director of Platform One. Platform One was started in response to the publication of what's known as the DevSecOps reference design. And the DevSecOps reference design is really the template for how the department is supposed to rapidly and securely deploy software. The predominant issue is it's full of all this different technology that quite honestly the department's just not very familiar with. And so Platform One team formed as sort of a response to become the easy button for the department. Our sort of role across the entire enterprise is to work with different program offices, work alongside them to basically find solutions to the problems that they have, and then take those solutions and then offer them up to the rest of the enterprise. And so it's sort of a solve it once, and then give everybody the cheat sheet as you go through. We're still pretty young in our journey ourselves. We're about less than a year old, but we're already supporting over 30 program offices across the DoD. It's across all branches of the department. We have Marine Corps, Space Force, we have Army, Navy, obviously Air Force, and even Coast Guard that we're supporting today.
That's great. So it sounds like while Platform One has laid the foundation for a lot of reusable computing methods and architectures, not only at the architecture level, but also the accreditation level, which we know is often the harder approach within the government. That's great for the data center, but how would you translate everything you've learned and all the agility that you've accomplished within the digital computing space and actually apply it to the edge?
Yeah, so that's actually a great question. So Platform One, how we do our deployments, we have a product that we internally refer to as Big Bang. It's our IAC and CAC that forms that declarative state as we go to any new environment. And so we use that exact same declarative state, with some small adjustments, whether we're going to like an AWS environment or whether we're going to a whether we're going to a cloud environment or an on-edge deployment. Really, the specific use case we're trying to address is all of our weapon systems, for the most part, live on the edge. And so if you actually look at how are you going to define this repeatable process to deploy this platform across all these weapon systems that are all different, made over the course of, really decades. We have aircraft that were designed and built 50 years ago, and then we have aircraft that were designed and built and coming off, performing their first flights, sometimes in the last, couple of years. So they're very different. And so all of these edge systems are fundamentally, from an infrastructure level, kind of different. And we need to abstract that from the rest of the tech stack. And so, as mentioned, Kubernetes is a huge part of that. Kubernetes forms is a major component of the DevSecOps reference design. And we take, all the lessons learned that we have in our cloud environments, performing, day two operations across, currently, for commercial world, it's not a large user base, but for the department, we have, over 10,000 active users in our environments. A lot of times things break, as everybody knows, keeping things up in production. We take all of those lessons learned and then deploy it against these edge systems.
Well, thank you, gentlemen, so much. I really appreciate your well thought out answers and your commitment to our national security and empowering our warfighters and those throughout the public sector. We're all a little bit safer because of you guys, but thank you so much for the great conversation today, and take care.
Thanks for having us.
Thanks.